In April 1815, a volcano on a small Indonesian island erupted with such force that it became the loudest sound documented in human history up to that point. 16 months later, in June 1816, snow fell on New England. Crops failed across Europe and North America. Famine killed people on 3 continents. The connection between the two events was not understood for over a century. Mount Tambora sits on Sumbawa, an island in eastern Indonesia. Before April 1815, it was a stratovolcano about 4,300 meters tall, a recognized peak in the regional Dutch colonial maps. After April 1815, its summit was gone. The volcano lost roughly 1,500 meters of elevation in a single eruption. The eruption began on April 5th and reached its main paroxysmal phase on April 10th and 11th. Modern volcanologists classify it as a VEI7, the highest classification of any historical eruption in the past 1,300 years. By total ejected material, somewhere between 100 and 160 cubic kilometers of rock, ash, and pyroclastic material went into the atmosphere over the course of about a week. For comparison, the 1980 Mount St. Helens eruption ejected about 1 cubic kilometer. Local death toll on Sumbawa and the surrounding islands, from direct volcanic effects, pyroclastic flows, tsunamis, ashfall, has been estimated at over 70,000 people. The total population of Sumbawa was reduced to approximately 2,000 survivors out of a pre-eruption population estimated at 12,000. The eruption was heard by Sir Stamford Raffles, the British Lieutenant Governor of Java, in Yogyakarta, 1,200 kilometers away, by the British garrison on Sumatra, 2,600 kilometers away. The sound, on later analysis, propagated as a coherent atmospheric wave that took roughly 3 hours to reach the most distant observers and was loud enough to be mistaken for cannon fire. By the standard loudest documented sound in history measure, Tambora is exceeded only by Krakatoa in 1883. The destructive force of the eruption was geographic, the Indonesian archipelago. The lasting global effect came from a smaller, more diffuse ejector, the sulfate aerosols. When a sufficiently powerful eruption injects sulfur dioxide into the stratosphere, the gas reacts with water vapor to form fine droplets of sulfuric acid. Those droplets are too small to fall out quickly. They drift in the upper atmosphere for 1 to 3 years. They scatter incoming sunlight back to space. The Earth's surface receives less solar energy. Temperatures fall. The Tambora eruption injected an estimated 30 to 150 teragrams of sulfur dioxide into the stratosphere. Ice cores from Greenland and Antarctica preserve the resulting sulfate deposition layer, which is one of the largest in the Holocene record. Within months, the aerosol cloud spread around the globe along the prevailing high-altitude wind patterns. By the boreal summer of 1816, the entire Northern Hemisphere was sitting under a thinner-than-normal solar input. Northeastern North America, New England, Quebec, the Canadian Maritimes. May 1816, heavy frosts and unseasonable cold. June, snowfall in central Vermont and New Hampshire, recorded in farm diaries from Maine to Pennsylvania. July, frosts that killed standing crops in their fields. August, sustained cold that prevented the surviving crops from ripening. Western Europe. The summer of 1816 was the second coldest in recorded European history, with average temperatures roughly 1 to 1.5 degrees Celsius below the long-term average. Persistent rains across Britain, France, Ireland, and the German states ruined wheat and rye harvests. The price of grain doubled or tripled in many regional markets. Famine. The estimated global excess mortality from the 1816 weather and its effects on the most cited reconstructions is in the low millions. The famine extended into 1817 as the dependent next year crops also failed in many regions. China experienced widespread rice crop failure. India experienced a cholera outbreak attributed in part to the disrupted monsoon. In Switzerland, Geneva, Lord Byron, Mary Godwin, later Mary Shelley, Percy Shelley, and John Polidori spent the cold, dark, wet summer indoors at the Villa Diodati. Mary Shelley wrote the first draft of Frankenstein. Polidori wrote The Vampire, the founding text of the modern vampire genre. Byron wrote the poem Darkness, which begins, "I had a dream, which was not all a dream. The bright sun was extinguished, and the stars did wander darkling." Contemporary observers recognized the 1816 weather as anomalous. They did not connect it to Tambora. The connection was not technically possible to make. The eruption had occurred 16 months earlier on the other side of the world, and there was no atmospheric science of stratospheric aerosol transport to suggest such a delayed and distant linkage. Speculation at the time included sunspots, Atlantic Ocean currents, divine punishment for various national sins, and, among the more secularly inclined, atmospheric effects of a recent comet. The connection was first proposed in the 1880s by the climatologist William Humphreys, who was working on the broader question of what large eruptions could do to global temperatures, motivated in part by the cooler weather following Krakatoa in 1883. His work matured through the early 20th century. By the 1920s, the Tambora 1816 connection was the consensus explanation in the climate science community. Modern confirmation came from ice cores. Greenland and Antarctic ice cores preserved a clear sulfate spike in layers dated to 1815 and 1816, matching the Tambora eruption. Tree rings from across the Northern Hemisphere preserved a clear cooling signal in 1816. The match was unambiguous. The Year Without a Summer is a load-bearing case study in modern climate science. It is one of the cleanest natural experiments available for the question, what happens to global temperatures if the upper atmosphere is suddenly seeded with reflective particles? The answer, from Tambora and from the smaller subsequent eruptions of the Krakatoa type, is consistent. Global temperatures fall by something like 0.4 to 1 degree Celsius per major eruption. The effect lasts roughly 1 to 3 years, and the geographic distribution of the cooling is uneven. This case is the empirical basis for some of the more cautious modern proposals around solar geoengineering. The proposed delivery mechanism, controlled high-altitude injection of sulfate aerosols, is essentially what Tambora did naturally. The empirical evidence that it works comes from 1816. The empirical evidence about what happens to crops and to people in the year that follows also comes from 1816. A volcano in eastern Indonesia took its own summit off in April 1815. The summit, in the form of fine sulfate droplets, drifted around the world in the upper atmosphere for the next 3 years. In the second of those years, in June, snow fell on Vermont. Crops died. People starved. A 19-year-old in Switzerland wrote a novel about a created man. The connection was not made for 70 years. The mechanism is now textbook climate science. The next time an eruption of this size happens, we will know what to expect within hours.